First experiment, lighting a bulb. Components required: 2 1.5 volt battery, light bulb, switch and connecting wires. Here we have 2 1.5 volt battery which are connected in series. Current always flows through a closed path. The light bulb is connected to that battery through a switch and connecting wires. When the switch is on, the electric current passes through the filament of the bulb. The filament has a lot of resistance to electricity. As a result of this resistance, the filament heats up and starts glowing, thus converting electrical energy to light energy. Experiment 2. Electromagnetism. Components required: copper wire wound on a nail or screw, 2 1.5 volt battery, switch, a lightweight pin, connecting wires. The screw is wound with a copper wire. The two ends of the copper wire are connected to the two ends of the battery supply with the 3 volt battery supply with the help of connecting. When the switch is on, electric current will flow through the copper wires wound around the screw. This will set up a magnetic field around the screw. Since the screw is placed in this magnetic field, it will make the screw a magnet, temporarily known as electromagnet. It is known as an electromagnet because it gains the property of magnet only for the duration of electric current flow through the copper wire. It is no longer a magnet when we switched off the supply. When the screw is an electromagnet, it can attract other conducting metals such as a pin as shown here. A magnet has two poles, north pole and south pole. Different types of permanent magnet: bar magnet, ring magnet, and horseshoe magnet. Magnets have the following properties. Opposite poles attract. We can see the south pole of bar magnet attract the north pole of bar magnet, attracting the south pole of horseshoe magnet. Similarly, the south pole of bar magnet, like poles, repel. South pole repels south pole and north pole repels north pole, as seen from here.